Good morning, Data Plus. We are Team 12, and we are excited to share with you guys our efforts this summer in understanding voting patterns and interactions with gerrymandering. We started out with many questions earlier this summer, but at the highest level, we knew we wanted to better understand the space of possible election outcomes and voting patterns in the state of North Carolina. So we had access to historical election data from 2008 to 2016 at the precinct level. And this included number of votes for each party in each election, such as lieutenant governor or secretary of state, as well as demographic data, although we tended to focus on the vote outcomes of each election. We also had access to synthetic maps created by the quantifying gerrymandering team's ensemble method, which generated unbiased maps that covered all possible outcomes of elections. We used both of these data sets to better understand elections and identify gerrymandering in North Carolina.
All right, so the first thing we did was we took a look at a few methods for clustering the data to try to find structure in it. So in order to extract the critical features of the data, we used PCA, where the machine generated a set of features which it thought were useful. And then we plotted each of the elections based on these features and then clustered them using k-means to try and figure out which elections were most similar to each other. And interestingly enough, the clusters roughly corresponded to the election years, with 4 clusters. One corresponded to 2008, one to 2016, one to 2012, and one to the midterm elections. After that, we performed a different form of clustering where instead of starting with the PCA, we started with just the elections themselves and placed them in a distance metric that we created based on how different the results of the election were after run through a map. When we did this, we agglomeratively clustered them based on this distance metric. And interestingly enough, the result of this agglomerative clustering gave us almost the exact same metric or the exact same clusters as the k-means did, which is a pretty exciting result because that suggests that the results we found from the 2 clustering methods weren't some structure that we imposed on the data, but there's actually something fundamental about the elections that sticks them in these clusters.
So the reason we wanted to cluster the elections is that we wanted to create our own artificial election space. So this summer, we explored 3 different generated methods to create synthetic elections. The first one is multivariate Gaussian. It is on the left of the second column. And the second method is uniform swing. And the third method is bootstrap. So for multivariate Gaussian, because just as Grayson said, we found that elections in the same election year typically have similar voting patterns. So for each year, we generated a multivariate Gaussian model, and then we sampled 300 election samples from the multivariate Gaussian models as our synthetic elections. And for uniform swing, it is a traditional method that swings all precinct democratic vote share by the same amount so that we can preserve the voting patterns and we can reach the target democratic vote fraction. As you can see on the first row of the second column, we did some analysis of the districting maps. The first row is the 2016 map. The second row is the current congressional districting map. And the third row is a random ensemble plan from our ensemble, collections of ensembles. And the fourth row is a summary of different maps. And we found that the 2016 map is a clear outlier. And we identified gerrymandering in the 2016 map, but we are still not sure about the current congressional districting map. At the bottom of the second column, we have the third method, bootstrap. And the results are quite similar, and we can discuss it later. And next, Danny will talk about the swing methods.
To ensure the overarching patterns of these synthetic elections match those found in historical election data, we began researching uniform absolute voters. So this is an alternative swing to the standard uniform swing, which, as James said, modifies each precinct to meet the statewide Democratic vote share. This alternative statistic takes into account voter turnout and vote shares. In future studies, we hope to see that the statistic preserves patterns in elections like uniform swing does. Uniform absolute voters is potentially another tool we can use to understand the space of elections and evaluate gerrymandered plans.
We've got a couple different directions that we'd like to take in for future work. One of those would be to analyze more maps with these plans. In particular, all of the methods involving multivariate Gaussians and synthetic elections could pretty clearly show that the 2016 map was gerrymandered. But it seems that the more recent map it's less clearly gerrymandered. So there's still work to be done to determine whether that is definitively a gerrymander. So we would like to do more analysis on that to see if we can find a clearer pattern. And in addition, we would like to test other methods for generating elections. For example, we would like to try to interpolate between elections, either in terms of the voter turnouts or the voter proportions. So, for example, we could either assume that everyone votes the same way, and then that people just turn out differently in different precincts where perhaps the Democratic or Republican fractions are different, or we could assume that everyone comes out in the same fractions, but the how they vote changes. And both of these methods give us a method for interpolating between elections, and we would like to test both out and see if we can figure out what the most reasonable way to draw an intermediate election between two existing elections is. So thank you so much for listening to our presentation. And sorry, I guess we can go back real quick and do the bootstrap stuff.
Okay. Sorry for that. So we also we use the bootstrap to generate new elections. Each synthetic election is a mixture of several different real elections in random proportions. According to the four cluster we generated, we created hundreds of new synthetic elections by bootstrap method. These elections were uniformly swung to 50-50 for Democratic Party and the Republican Party. Then we calculate how many representative seats the Democratic Party can win in different maps. We transform the number of seats into continuous value to make it more suitable for analysis. The x-axis is Democratic seats and the y-axis is number of maps. You can see it looks like a normal distribution. The red vertical line is the value of the real map used in 2016. It's an outlier in this plot, so it's very likely gerrymandered. And the purple line is the map used currently. It looks much normal.
Thank you all so much for coming to our talk, and I'll open the floor up for questions.
Thanks all. So at this point, please feel free to ask questions. Please feel free to ask them to zoom in on particular figures if you want to sort of dive into them and digest them. But just this is our time to sort of have a conversation about the poster.
So I have a question that may not specifically be related to figures, but I'm just curious, as you think about, the future work and what your next steps would be with these data sets, what you think the application might be like if you were to say, get to present this to like a policy team or anything like that. I mean, could you guys talk a little bit about the ways you would see this, this being applied?
I think the most immediate application is that following the 2020 census, there's going to be a redistricting event in North Carolina as we gain a new seat. And I guess we didn't look specifically very hard at at this redistricting event, but I think the folks on the team, I think Greg, Jonathan, and Eric were have been thinking a lot about that, and I think that is the most immediate application of this work. Will be that.
I would also go to say, sorry, that this has been used in court before to prove that there has been a gerrymandered plan. So I think along with Grayson's point that we could really use these methods and our new generative synthetic elections to advance that in hopefully and point out other gerrymandered plans and get better justice.
Robert, do you have a question?
Yeah, I was just following up on Anna's question. Last week, I had a meeting with folk from Duke that run this Duke in DC program, where they put on events at the Capitol for congressional staffers. And it occurred to me that this might be a project that would be of interest to staffers. Would you guys be interested in signing up?
That sounds interesting. I guess I'd be interested in the details of that. I guess would you mind if we got in contact with you after this meeting about
Sure, that would be great. I think that they're not actually sure about details either. They have this idea at the back of their mind that there's perhaps 100 Duke alumni who work on the Hill in some sort of form, and that they might be interested in reconnecting with Duke and with students at Duke. And so they're not quite sure what this event might look like. They just know that they'd sort of like to put on an event. They don't even know quite what they'd like to talk about, but this was certainly a possibility that intrigued them.
Hi, I'm Asher Hildebrand, an interloper from the public policy school, from the Sanford School, and working with Professor Hirschlag and some others. And I think also a former congressional staffer, so I echo our friends' thought that there might be some interest in this. What I wanted to ask you, though, as someone who doesn't have a strong quantitative background, is you could explain to me how the 2016 analysis that you did differs from kind of previous analyses that have been done of that 2016 map. What improvements did you make to the method relative to previous ones? And then I'm also trying to understand a little bit more just the limitations of the 2019 map and why you think that needs additional analysis. Was it just not having enough bandwidth, computing time, et cetera, to also do the full analysis on that, or are there other limitations that prevented you from doing that?
Yeah, Danny, could you zoom in for the second column? A little bit more, maybe.
Yeah, could you this slide or?
Yeah, that's great. Yeah, could you shift it a little bit to the left? Yeah,
Do you
yeah.
want both columns?
Yeah, both. Yeah,
Okay.
both.
All right.
Yeah.
Thanks.
Yeah. So the first row represents our analysis of the 2016 map. So that map was struck down by the court, and on the first column here, we have two lines. One is blue line, and the other is yellow line. So the blue line represents the percentile of the 2016 map compared to our nonpartisan ensemble maps based on the number of Democrats elected in congressional seats. So as you can see, when the synthetic elections are between 47% to 52%. The percentile, the blue line is close to 0%, and it's very stable. So that means that as the Democratic vote share increases, the number of Democratic seats elected has not changed. Compared to other ensemble maps. However, if could you scroll down a little bit, Danny? Yeah. So for the third row, we have analysis of a random ensemble plan. As you can see from the third row, so the blue line fluctuates a lot, which means that the percentile fluctuates a lot. So the plan is very volatile. It does not just stay at 0%. And the yellow line represents the number of Democratic seats elected, and the slope represents the level of responsiveness to a change of vote. So for the third row, the yellow line steadily increases as we increase the Democratic vote fraction. But for the first row, sorry, could you scroll up a little bit? Yeah, so the yellow line is pretty flat until the Democratic vote fraction reaches 52%. I'm not sure if that answers your question.
Yeah, that's helpful. I guess I'm trying to understand, so is it the vote swing analysis that you think is kind of a new contribution, or one of the new contributions here that you're making?
Yeah, because we are trying to understand the election space, and we explored different generative methods. One is multivariate Gaussian is on the first column, and the results from the second column are quite similar as the first column. The second column is uniform swing, but we're still not sure if the election samples, the synthetic elections we got from multivariate Gaussian and uniform swing are valid for the analysis. So we still need some more further analysis on that after this project.
Okay, thanks. That's helpful.
Thank you.
Robert, looks like, Robert, you have another question?
Yeah, I do. So just for the student team, would it be a fair summary to say that in some part, the purpose of this project is to be able to do, or to be able to explore what if questions without actually running an election? So you make a map, and then the obvious thing is, well, what if this happens, or what if that happens?
I think that's a pretty fair summary. Yeah, I guess James, you can take this one.
Yeah, because we're trying to create some synthetic elections and then run those elections based on different districting maps and see the results, and try to identify some gerrymandering if possible from them.
I think also it's worth noting that like in history, we've really only had so many elections that we have data on. But if just based on like the direction of the wind or whatever, any number of elections could have happened. Say on like in November of 2016, November of 2012, November of 2008, and with, I guess what we would like to do with this analysis is find, like you were saying, all of the things that could have happened, and say, what if those had happened? Would this gerrymandering still look as bad as it does under the real elections?
Let me ask just a third question. So what would you say? So I mean, there's all of these public policy implications. What were the interesting mathematics and computational stuff that you did? What interested you about that side of the project?
As somebody who comes from a not super mathy background, it was very interesting for our weekly meetings to have two mathematicians in the room discussing different techniques and deciding what was the best way to go. We did a lot of research into each of the ideas, so we got a good look into just that research process and what it means to just explore the data with just a very general direction. So I think that part was really cool for me. But yeah, I really liked our weekly discussions and the math fights, I'll say, that our team involved in, and then are going back and making sure all of the students understood what was really going on, especially for me. I knew I was struggling with that part a little bit in the beginning.
And I think the most interesting for me is to learn how to use the ensemble method to generate the maps and the elections, and for the second question you just asked, what if. So in this project we try to explore what if Democratic Party win more votes than how many representative seats they can win. What if we change the map slightly? The result will be. And what if we generate a new election? Then the result how looks like. So that's yeah. We do some create some. To answer, explore the result of many what ifs. That's very interesting for me.
Grayson or James, you guys want to answer your perspectives on that?
Yeah, I guess my the thing that I thought was most interesting was in all of these analyses, like we did stuff like PCA, where PCA is not necessarily guaranteed to give meaningful features, but whenever you like looked at the things that PCA did, or look at how a certain election would be plotted on a map, it always felt like there was kind of a story in the data. And I'm not really used to taking a matrix and that matrix actually having like really a tale to tell about every data point in it. And I thought it was really interesting how that really seemed to happen with this data. Like every single bit of information in it seemed meaningful due to some political happening that had happened during that election.
For me, I think even though the generated methods we use, for example, multivariate Gaussian and uniform swing, might not be 100% rigorous, but I think throughout this project, we got some interesting signals from our analysis. And I think that motivated me to explore further about this gerrymandering stuff. And I think it's very interesting to analyze public policy issues from a quantitative perspective.
Thanks a lot for the question, Robert. I really liked it. I enjoyed the answers as well. So we probably have time for one more question before just give people a minute to stretch their legs between the presentations. Is there anything else anybody wants to touch on, or to the students? Is there anything that you would like to share with the group before closing off for your project on the summer?
I know we as students definitely enjoyed working with our project leads, Eric, Nick, Greg, and Jonathan. And it was really, really fun and a big learning experience for me. So thanks for that.
Yeah, same for me.
Yes, thanks so much.
Yeah. Yeah, I also learned a lot from Jonathan, Nick, and Greg, and yeah, Eric. Thank you very much for this summer.
Yeah, it was a pleasure to work with you.
Yeah, it was great. You guys did a great job.
Yeah.
Thank you guys so much for sharing this project. It's really fascinating. And I just wanted to say to Grayson's point that, you know, what you said about there being a story in the data, I find highly compelling. And I would be, you know, I'm inspired and hope that you are to sort of find more ways to tell that story and make it available, you know, outside of your own academic communities to others. Again, like, you know, in a policy space, obviously, and in other ways too. So thank you guys so much. Great presentation.
Can give our virtual round of applause, either on video or and so we'll just take a few minutes to let people kind of stand up if they need. We have a 2-hour chunk, so I think having a couple of several minute breaks is a good thing to do. So we will reconvene here at around 10:30, and we'll move on to the next presentation, which is going to be on feature engineering for unknown web attacks.
Robert, I just wanted to give you a slightly different answer to your question of what ifs.
Yes, go ahead.
He's not here.
Oh, he's
No,
here.
I am here.
I mean, what if has the implication that you're trying to be predictive?
No, not really. It's you're trying to educate yourself about the likely consequences.
It looks like Jonathan just dropped for some reason. But yeah, I think that's where Jonathan was about to head.
Yeah, I mean, in some sense, when you run a networking company, right? You want to make a model of your network so that you can answer questions like, if I take this thing down, what are the likely consequences for these different sorts of traffic?
Yeah.
And so that's what prompted my question.
Yeah. I think it's a concise and nice way to frame it.
Yeah,
and I
because
think
in some ways, when you say this is gerrymandered is kind of a polarizing term.
Yeah.
But if you say, you know, if you draw boundaries in this way, then, for example, the Democratic Party has to get 53% of the vote in order to get anything beyond 3 seats.
Right. And then
right?
you can kind of probe the variation that you might expect to see the probability of that statement.
Exactly.
Yeah.